Hey, welcome to the Explainer. Today, we are cracking a secret code. A code you use literally every single day. We're going to uncover how something called place value gives every single number its true meaning.
So, let me ask you this. How is it possible that the number 5 can be worth 5, but also 50 or even 500? I mean, it's the same digit, right? It feels kind of like a magic trick. But trust me, it's actually an incredibly clever system.
And you know what? The secret is surprisingly simple. It really is all about location, location, location. Yep. Where a digit sits inside a number, that's what gives it its real power. So let's dive into our first section, the power of position. We're about to unlock exactly how this whole thing works. And I promise, by the end of this, you're going to see numbers in a completely new light.
Okay, so the official name for this idea is placed value. And it's not just some neat little math trick. It is the absolute foundation of our entire number system. I mean, without it, numbers would just be, well, a total mess.
All right, let's make this real. Take the number 7. If it's in the ones place, okay, that's simple. It's just 7 apples. But what if we slide that same 7 just one spot to the left? Suddenly, it's 7 groups of 10 apples. That's 70. Slide it over one more time. Now it's 700. It's the exact same digit, but its value just skyrockets, all based on where it's sitting.
Okay, so how does a system like this stay so perfectly organized? Well, think of it like it's following a simple, repeatable blueprint. Let's decode that blueprint right now.
This is it. This is the golden rule that makes everything work. As you move to the left in any number, each new spot is worth exactly 10 times the value of the spot to its right. That's it, that one simple rule. It's why we call it a base 10 system, and it is the key to everything. So check this out. We start all the way on the right with the ones place. Take one step to the left, and boom, you're in the tens place. That's 10 times bigger. Take another step left to the hundreds. You guessed it, 10 times bigger than the tens. It is just a super simple, predictable pattern that can go on forever. Okay, theory time is over. Let's put this blueprint into action. We're going to take a totally normal number, 345, and use our new code-breaking skills to see what it's really made of. All right, let's start from the right and work our way left. First up, that 5. It's in the ones place, so its value is, well, just 5. Easy. Next, the 4. It's sitting in the tens spot, which means it really stands for 4 groups of 10, or 40. And finally, all the way over on the left, that 3 is in the hundreds place, giving it a value of 300. You know, this whole process of breaking a number down like this, it actually has a name. It's called expanded form. It's awesome because it lets you see all the individual building blocks that make up the number. So 300 plus 40 plus 5, it all adds up perfectly to 345. Pretty cool, right? Okay, that's great for whole numbers. But what about all those numbers that are smaller than 1? Well, the really cool part is, the system doesn't just stop. The exact same logic just keeps on going on the other side of the decimal point. So if you look to the right of the decimal, it's like a perfect mirror image of the pattern we just saw. But instead of getting 10 times bigger with each step, we get 10 times smaller. So we go from tenths to hundredths to thousands and on and on. And here's a little tip. See that TH at the end of the word? That's your big clue that you're talking about a piece, a fraction of a whole number. You know where we see this all the time? Money. It's the perfect example. Let's say you have 5 pesos and 75 centavos. That 7 isn't 7 whole pesos, is it? Nope. It's in the tenths place, so it means 7/10 of a peso, or 70 centavos. And that 5? It's in the hundredths place, meaning 5/100ths of a peso, or 5 centavos. See, you use this stuff all the time without even realizing it. Okay, I gotta point out a super common mix-up. People get tens and tenths confused all the time. Just remember, tens with no the are on the left of the ones place. They make numbers bigger. Tenths with that th sound are on the right of the decimal. They break things into smaller pieces. They sound almost the same, but trust me, they are worlds apart in what they're worth. All right, so now you've learned the secret code for big numbers and for small numbers. This isn't just some boring thing you learn in math class. It's a legit superpower for making sense of the world.
And you'll find you use it everywhere. Seriously, when you're counting your money, when you see some huge population number on the news, when you're measuring something, even when you're just tracking scores in a game. At the heart of all of that, you're using place value to understand what's going on.
Okay, enough talk from me. It's time to test out that new superpower of yours. I've got a quick little pop quiz for you. Just 2 questions. You ready? First question is, in the number 6,942, what is the value of the 9? Go ahead, take a sec to think. Did you say 900? If you did, you are absolutely right. That 9 is sitting in the hundreds place, so its value is 900. Nice job. All right, one more for you. This one's got a decimal, so watch out. In the number 58.6, what place does that 6 represent? And the answer is the tenths place. That's the very first spot to the right of the decimal. See? You've totally got this. And really, that's the whole point. You've cracked the code. That mystery of how one little digit can have so many different values, it's solved. And now you have the power to read, write, and understand pretty much any number you come across, no matter how big or how small. So I'm going to leave you with this one final thought. This place value system, it goes on forever. So now that you know the rules, now that you've cracked the code, what is the biggest, most mind-blowing number you can possibly imagine? Thanks so much for joining us on The Explainer.